record. Okay. All right, so today we're going to do investigation 15A, which is about waves. It says a wave is a traveling form of energy that carries oscillations from one place in space to another. Sound and light are both waves and share characteristics of frequency and wavelength with familiar water waves. This investigation will use a wave simulation to characterize the properties of frequency, amplitude, and wavelength. All right, so here we can see wavelength. How far is it from crest to crest or from trough to trough? That's like how far apart your the oscillations are, right? And then you have the amplitude. How high or low is that crest or trough? And then they talk about frequency, which it's hard to see frequency on this picture, but waves that are super close together have a higher frequency, right? Like this. So here we see, this is a seismograph. It measures earthquakes, right? And so we start seeing some activity, and then there's huge earthquake, large amplitude, right? It's all about energy. So the more energy you have, the higher the amplitude, the lower the troughs. More frequency means more energy, right? So these are all closer together, and then it kind of tapers off, the amplitude calms down. Yeah. So that's what we're messing with today. So you're going to click on this simulation, and I'll put the code up there so that if you don't have the code, you can log in. And this is then you click on this white button here. So this says part 1, match a wave's properties. Open the interactive simulation. You will create a mathematical model of a wave, which is the red line. Okay, so let's play it. And what we're supposed to do is we're supposed to match the blue waves representing the water. So we have the red line is a mathematical model, and the blue line is the water. It says adjust the amplitude and wavelength of your model to match the blue wave. So what we want to do is we want to mess with these numbers, the ones in white here, wavelength, frequency, amplitude, and we want to match the blue wave. It says run and pause the waves, adjusting the frequency until the red circle bobbing in your model matches the bobbing of the floating. Okay, so we're just going to mess with this thing until we get a score of 90 or better. And you're going to answer these questions. Like question A, describe how changing the amplitude changes the waves. Okay, so let's change the amplitude. Well, what if I go from 30 to 10? See, so by changing the numbers, I'm changing the form of the theoretical or the model, right, which is the red line. All right, so my score went down. I got a 16%. All right, so that wasn't the right thing to do. So you just gotta play with these things until you get a 90 or better. So let's pause this. Now, wavelength. So let's look at from crest to crest or trough to trough. Let's see how many squares are there. 1, 2, 3, 4, about 5 squares for the wavelength. So it looks like each square is about 10 centimeters. So the actual wave, let's count, let's see, let's get a good, there we go. From crest to crest, let's see, we've got 1, 2, 3, 4, 5, 6, 7. So there's 70 centimeters between, that's what the wavelength should be. So let's see if that helps. I'm going from a score of 29 to 41. That's not bad. Okay, let's look at that. So a little better. So my frequency Which one's moving faster? Looks like the ball is moving faster, so I need to increase my frequency. 41 to a 74. Look at that. Better. So that's all you're doing is you're messing with these numbers, trying to match. And then you'll answer the questions right on there. Draw a sketch showing the amplitude of wavelength of this wave. Calculate the speed of the wave. Show your work. So once you get a 90 or better, then you could pause it and draw it and answer all the questions. Let's look at the assignment. So make sure you make your own copy of the assignment. Just type on here what your thoughts are. To calculate the speed of a wave, this was in the notes, and so what you'll do, and this is what the next assignment is as well. We could insert a drawing. So to calculate the you could draw it in here like I'm going to do. Velocity equals frequency times wavelength. Wait, that's not wavelength. Sorry. That's wavelength, I believe. So then you just multiply those things. So you got wavelength was, on the crest. So on the crest or on the wave, this is the wavelength, right? I keep on doing that because that's how I draw my A's. Sorry. But that's wavelength. So this distance from crest to crest is your wavelength. So on my thing here, I have 70. This is not correct, but because I only got a 74. So wavelength is 74. And what's my frequency? 2. And frequency is equal to 2. So then the velocity is just 74 times 2, which is what? 140 plus 8? 148? Meter or centimeters. It's actually centimeters per second, I guess. And that's pretty big, so you can make that smaller. All right, so part 2, and we're going to go over more calculations in a minute on the other worksheet. All right, next, they're asking you to, if you have a Slinky, that'd be pretty cool. Then you could do transverse and longitudinal waves. I'll put up a video because I'm sure people on YouTube have already made this video, making a transverse wave and a longitudinal wave with the Slinky. And then you just answer these questions once you've seen the video, or you could do it yourself. And that's basically the assignment.